Okay, so when we look at these graphs, sine x minus 1, sine x plus 2, you might be able to predict what this is, but I encourage you to graph it. That number on the outside is going to be a vertical factor, and it's going to affect our graph, and that's going to change the vertical positioning. Okay, so there's my sine x graph. If I have sine x minus 1, what that's going to do is, it's on the outside, so it's going to shift everything down 1. So I'm going to start down here. I'm going to go up to 0. It's going to go back to the middle here. It's going to go down to -2, and then back up to the middle. So I'm just going to draw my center line there, and the original center line has been shifted down 1. Okay, if I graph then my plus 2, okay, the plus 2, what will end up happening is everything gets shifted up 2. There's my middle line. Oops, my scaling's not that great. So I'm going to go up, back to the middle. Okay, it's going to go down, and back up. So everything's been shifted up 2. Okay, so that's a vertical shift factor that's going to be on the outside. So we're going to start putting these together now when we're graphing these. So if I have my y equals -4 sine x minus 3, well, what's happening? What's the transformation? I'm expanding by 4, I'm flipping it, I'm shifting it down 3. So I need to kind of organize some stuff here. There's really 4 main things I need to know when I'm graphing. My amplitude. Okay, in this case, my amplitude I can get from my vertical expansion. Vertical expansion is 4. My horizontal shift. Okay, in this case, it's 0 because there's no horizontal shift. My vertical shift, okay, which is down 3, that vertical shift then allows me to find my middle line and the period. Okay, the period in this case, there's no horizontal compression or expansion, so that's going to be 2 pi. So I'm going to draw this in then. Okay, so I'm going to do this without drawing my original sine function. So to do this, I need some references. I want to know where it's going to start. Okay, that's my horizontal shift tells me where my start. My period is going to add on to tell me where I end. So if I'm going to start at 0, my period is going to then tell me where I'm going to end. So I'm going to end at 2 pi. Okay. Well, this is like a normal graph. I have my 4 quadrants. So I'm going to sketch my quadrants in just to make sure I have some reference there. The other thing now, so I've got my start and end. Now I need to know where my middle of the graph is. My vertical middle now. My original middle is here. Now I've shifted down 3, so I'm going to use 1, 2, 3 down. I'm going to go use this line as my vertical middle. So now I have my middle, I have my quadrants. I've kind of now framed how my graph's going to look like now. So start, use a period to find the end, use my vertical shift to find the middle. I split it up into my quadrants. Okay, and again, I encourage you to do a middle calculation or an average calculation. Okay, this one's already kind of set, so we don't really need to do it. But as we introduce a horizontal shifts with this, we're going to have to be a little bit more careful. The last thing is I'm going to use my amplitude and my flip to graph this. So I know my sine graph starts in the middle, so the amplitude doesn't affect it. My flip, though, is going to make it go down to -7. So the first quadrant, I'm going to go down 4 to -7. Second quadrant, back to the middle. The third quadrant, I need to go up to +1. Okay, so notice I'm using my amplitude now to go. I didn't start going up, though, because of that flip. So I'm going to go up and then back down to the middle. There's my sine graph. Okay, I've sketched my sine graph. The keys are organizing this information, using this information to get a start point, end point through the horizontal shift and period, get my middle line through my vertical shift, split it up into quadrants to be able to frame my sine and cosine functions, and then use the amplitude and flip to graph this function. Okay, down 4, okay, up 4. Okay. So the last one is a phase shift. This is going to make things a little bit more complicated to keep track of the x-coordinates, especially when the phase shifts are not nice. So if I graph this here, my sine graph, my basic sine graph looks like that. Okay. If I have a phase shift of theta minus pi over 2, I've shifted it to the right pi over 2. So what ends up happening is the graph shifts one quadrant. So every point gets shifted one quadrant. That point gets shifted over here. And I'm going to end up having a horizontal shift to the right plus pi over 2. Okay, so that's what that graph looks like. If I have theta plus pi over 3, I'm going to go to the left pi over 3. Now this is a little bit harder because now I've got I'm going to just mark my original 90-degree quadrant. So it's going to be like this, this, and this. But now my shifts are not one full quadrant or one full increment here. So I need to find out where pi over 3 is. So pi over 3 is going to be here. Okay, so that's my starting point. And every point shifts back pi over 3. Okay, so that's where the next pi over 3 segment is going to be. This is going to shift back pi over 3. Okay, so there it is. This point is going to shift back pi over 3, so right about there. Okay, and then this point shifts back pi over 3 right about there. Okay, so there's my graph that's been shifted to the left, pi over 3. Now, we do need to figure out these positions. So this one, we can kind of eyeball, but we're going to try to come up with a better way to come up with that. Come up with those positions. So we need to be able to locate those positions. So let's try one here, and then we'll work on getting those positions. Okay, so this one is a shift of pi over 3. So like with the other ones, I want to just kind of start getting the habit of giving my main points here. So my amplitude of 1, my horizontal shift is, well, in this case my horizontal shift is left pi over 3. My vertical shift is 0, so it's along the middle. And then my period doesn't change, it's 2 pi. Okay, so really the only thing I change is the horizontal shift. But this makes a big difference in how I go about drawing this in. So here's my original y-axis. Okay, and what I'm going to do is I'm going to again figure out my start and end. So I'm going to go backwards pi over 3, so negative pi over 3, and then I need to add 2 pi or 6 pi over 3, and I'm going to end up at 5 pi over 6. Oh, sorry, that's not 5 pi over 6, is it? What is it again? It's 5 pi over 3. 5 pi over 3. That's my start and end points. So I need to have my middle and my quadrants. Okay, my vertical shift is 0, so there's my middle line. Okay, and then you need to try drawing it. So I'm going to get you guys to figure out those locations and then draw it in.